Hello, this is Mrs. Ross, and this is lesson 18. This is up here. Let me see if I can. Lesson 18. And these are the starred problems. We define similar, congruent, and polygons in the practice set. So if you've forgotten, or if you didn't write those down in the back of your spiral, you might want to go back and watch that video. So, number 2, this function table shows the number of gallons output and a given number of quarts input. Copy and extend the table to include 5, 6, and 7 quarts. So let's see. What we know, and I think I have it in here somewhere, right here. Okay, so we know that 1 gallon is equal to 4 quarts. So let's go back. So 1 gallon is equal to 4 quarts. So you can see what they did here. 1 quart is 1/4 of a gallon. 2 quarts is 2/4 of a gallon, which is 1/2. 3 quarts is 3/4 of a gallon, and then 4 quarts is 4 gallons. So this kind of starts over because this is going to be 1 1/4 gallon. It's going to be 1 2/4, which is 1 1/2 gallons. This is going to be 1 3/4, and then this is going to be 2 gallons. So that's how that's worked out. Number 8, write each number as a reduced fraction or mixed number. So here I have 2%, which is 2 per 100, and I know that 2 will go into both 2 and 100, so 2 divided by 2 is 1. 100 divided by 2 is 50. That's our answer. Here I have, it might look kind of weird like this, so if I were to write it out, it looks like that. 12 over 20, so I know 2 will go into it. I think 4 will go into it. Let me see. So 12 divided by 4 is 3, and 20 divided by 4 is 5, and that's as far as that's going to go. And then here I have 6 and 15/20ths. That's what this is supposed to be. And I would divide by 5. This looks like it's both divisible by 5. Don't lose your whole numbers. So 6, and then 15 divided by 5 is 3. 20 divided by 5 is 4. All right. For each fraction, find an equivalent, same fraction with a denominator of 30. Okay, so here I have 4/5, and I'm trying to get to a denominator of 30. 5 times what gives me 30? 5 times 6. And so we'll do the same on the top. Here I have 2/3, and I'm trying to get to a denominator of 30. 3 times what gives me 30? 10. Okay, last one, 1/6 equals something over 30. 6 times what gives me 30? 5. All right, number 11. Draw a triangle with one obtuse, so this is greater than 90 angle. Okay, so my obtuse angle is going to look kind of like that. And then I'm just going to connect that. Oh, that's a triangle. Okay, and there's my obtuse angle. What kinds of triangles, what kinds of angles are the other two angles? So these are both acute. They're going to be less than 90. Okay. You don't have to look at page 126 in your book, but that's where this is from. What is the probability of spinning a 3? So let's see, how many 3s do we have? 1, 2, we have 2 3s, and then how many total possibilities do we have? 1, 2, 3, 4, 5, 6, 7, 8, 8. So the probability of spinning a 3 is 2 8ths, but we are reducing all of our fractions. So 2 divided by 2 is 1, 8 divided by 2 is 4, and the probability is 1/4. What is the probability of not spinning a 3? There's a couple of ways to do this. So the probability of not 3, you could do 4 over 4 minus 1/4 is equal to 3/4. Or not 3. So let's see, how many do we have of not 3? 1, 2, 3, 4, 5, 6. So I have 6 out of a total of 8. And then if I divide by 2, 6 divided by 2 is 3. 8 divided by 2 is 4. All right, so 15 would look like this. I know it looks kind of funny when it's hard to do divide when you're typing it out in a document, but this is what this looks like. We're adding. Okay, y plus 3/10 equals 7/10. And I want to know what y is. So I have to do the opposite of addition, which is subtraction. And then what do I do to one side? I have to do to the other side, right? So my y comes down. 3/10 minus 3/10 is nothing. My equals comes down. 7/10 minus 3/10 is 4/10. And then I have to reduce this. Always ask yourself, can I reduce this fraction? 4 divided by 2 is 2. 10 divided by 2 is 5. And that's my answer. All right, let me change colors here. Which properties are illustrated by these equations? So I have 1/2 times 3 over 3 is equal to 3/6. And I know that this is 1. So this is the identity property of multiplication. Because basically what I'm doing is I'm multiplying 1/2 by some form of 1 to get something that equals 1/2. Okay? Here I have 2/3 times 3 over 2 is equal to 1. So these are reciprocals, right? And that's the inverse property. All right, let me change colors. I think I did these out of order or something, because 13 I did. Okay, because I'm like, this is not going to tell a property. Okay, sorry. Let me write this in a form that's maybe a little easier. Just a reminder, my variable is second, which means I subtract. Remember, subtraction is always, you got to kind of second guess. Addition, you're always going to subtract, but subtraction, so I'm going to take 5/6 minus 1/6, and I get 4/6. When I plug this in, all of this works out. I can reduce this, and I should reduce it. Let's use 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So this would be your answer. All right, 5 7/10 minus 3/10. Okay, so 7 minus 3 is 4. We keep the 10 because we're subtracting. And then this is 5. So then I need to divide this by 2. Don't forget to take your whole number with you, right? 4 divided by 2 is 2. 10 divided by 2 is 5. All right, and here I have 3 over 2 times 2 over 4. I'm going to multiply across the top, which is 6. Multiply across the bottom, which is 8. Divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. All right, let's change colors. What percent of a pound is 8 ounces? So I know that 1 pound is equal to 16 ounces. So I'm looking at 8 over 16, which if I divide this by 8 and divide this by 8 is 1/2. And I know that 1/2 is 50%, right? 25. How many degrees is 1/4 of a circle or 1/4 of a full turn? Okay, so I'm not sure where this came from, but a circle has 360 degrees. Okay, so 1/4 of times a circle, 360, is going to give us 360 divided by 4, which I believe is 90, but I don't trust myself. Yeah, it is 90. So that's my answer. And then we do a very similar thing here. How many degrees is 1/6 of a circle? 1/6 of is times 360. We get 360 divided by 6, which is 30. That's not right. It's 60. See, there I go trying to do it in my head, and I just bleh. Sorry. Okay. What am I doing here? There we go. Use a protractor to draw a 135-degree angle. All right. So we're going to use this fancy smancy protractor. We're going to start at 0, and we're going to go this way, which means we're going to use these numbers on the inside. So you see we go up to 90. We're trying to get to 135. Here's 130. So let's see. Halfway through is going to be here. So, yeah, that's beautiful. Okay. That's the angle there. Nice straight line. A 135-degree angle is how many degrees less than a straight angle? So a straight angle has 180 degrees. It's basically a straight line, okay? So I'm wondering what this part is, right? So it's going to be 180 degrees minus 135, which is 45? Yeah. Let me change colors here. Refer to page 126. This is on page 126. So, which triangle appears to be congruent? Same to triangle ABC. So it needs to look exactly like ABC. I think it's this one, and you can call it however you want to call it. Well, it's actually, if it's congruent, then that means that it looks like B and Q are similar. BC is flat, QR is flat, so we'll make this R and we'll make this S. Because these, you'll see when you're dealing with congruent and similar triangles, you have to align the angles with one another. For instance, this angle is the same as this angle, so the B and the Q should be in the same spot, okay? Which triangle is not similar? Okay, so this just means same angle, different side length. Okay, so this is the same as ABC, but it's a little bit longer side length. It's going to be triangle XYZ that's not similar. And which angle in DEF, this is a D, I think I cut it off a little bit. Oops. DEF corresponds to the R, this one, in triangle SQR. So let's see, we have this side, it's either going to be D or F, and the R, goodness, goes straight away to the Q, so I'm thinking it's angle E. That doesn't look right. SR, if I flip it up, it's F, my bad. You got to kind of visualize it, and it can be a little bit difficult. Oh, that's our last problem. All right. Well, have a great day. Let me know if you have any questions.